Hey everyone, let's talk a bit more about the mole and about gram to mole to particle conversions. We have been talking about the mole as this number of particles that we know in any one relative mass, there are the same number of particles. But we haven't put a number of value to how many particles are actually in one mole. Well, the time is now. It is time to put a number so that you now know when we have 1 mole of any item, 1 mole of iron, a mole of gold, a mole of carbon, that you know how many particles that actually is. Okay, here it is. In 2018, the International Union of Pure and Applied Chemistry updated the definition of 1 mole, which is the unit, the SI unit, the official, it's a Système International, the official unit for the amount of a substance. And that value for 1 mole of a substance is 6.022140076 times 10 to the 23rd. This is exactly how many particles are in 1 mole of anything, which means that if I had 1 mole of carbon atoms, I would have exactly 6.022140076 times 10 to the 23rd particles. If I had 1 mole of gold atoms, same number. If I had 1 mole of carbon dioxide molecules, same number of particles. I could have 1 mole of anything. I could have a mole of cars, except that this number is so big, it doesn't actually make sense for something as large as a car. It's such a large number that it's really only useful and used for things that are really, really tiny, like atoms and molecules and other particles that build up our world, things that are really, really tiny. We'll meet some other flavors of particles as we go on this year, but it's really only useful for things that are really, really small, because this is a really, really big number. You see the scientific notation, but take a second and write this number out. There it is, not in scientific notation, but it's actually written out. This number is 602 sextillion, 214 quintillion, 76 quadrillion of anything. And again, this number can be used to count any tiny particle. Could be used to count anything, but only useful for tiny particles. This value, 6.022140076 times 10 to the 23rd, that number of particles in a mole, that number is called Avogadro's number. Avogadro actually didn't know this value, but in honor of him coming up with this idea that there were equal number of particles in a particular volume of gas at the same temperature and pressure, that was where this number kind of began. That was the birthplace of it. And so in his honor, once this number was actually determined, it was named after Amadeo Avogadro. And so this number, 6.022 times 10 to the 23rd, which is the digits we'll typically use in this class, this is called Avogadro's number. So we've been doing gram to mole conversions. We can now take this all the way to particles. So if we know how many grams of a material we have, we know how many moles, and we actually know how many particles are in that. So let's take a look at kind of our process, and then we'll take a look at 2 examples. Whenever we're doing our conversions, our number of moles is going to be kind of our central hub. So we already know that we can convert from grams to moles or moles to grams back and forth there using the molar mass from the periodic table for whatever the substance is. Now I have a new way to convert from moles to particles because Avogadro's number and just the first few digits are enough for the calculations we're going to be doing. So 6.022 times 10 to the 23rd, this is how many particles are in 1 mole. So we can use this mole as a new relationship to do conversions. Which means if I have a question like I have down below, how many atoms of iron are in a 5-gram nail? My plan is going to be to take 5 grams of the iron, convert this to moles of iron, and then from there I can go to atoms. So atoms of iron are the type of particle that we're looking at. I'm going to set this problem up both in proportions and dimensional analysis, and then we'll come back through and talk it through. On the left, I've set this problem up in proportions, and on the right, I have it set up in dimensional analysis. you'll see that regardless of how you choose to tackle this problem, your first step is going to be to convert from grams to moles, using the molar mass as your relationship. And then your second step is going to be to convert from moles of iron into atoms of iron using Avogadro's number, using 6.022 times 10 to the 23rd particles for every 1 mole as your relationship. Let's take a look at a second example. In this example, the question is what's the mass? And we know that we have 2.01 times 10 to the 22nd molecules of nitrogen, that's N2, in a breath of air. So we're going to run the same process, but backward. We're starting with number of molecules, that's our number of particles, and we're going to go from particles to moles, and then from moles to grams. Again, I'm going to write this out both in proportions and in dimensional analysis, and then we'll talk it through. So in this case, we have started with 2.01 times 10 to the 22nd molecules, and we're trying to first figure out how many moles there are. And so I took the value 6.022 times 10 to the 23rd, Avogadro's number there, and used that as my relationship to convert to moles, and got 0.0334 moles of N2. And then I took that number of moles of N2 and I used that to convert to grams using the molar mass from the periodic table. Now this nitrogen is N2, so I took 2 times the mass of nitrogen on the periodic table, which is 14.01, to get a molar mass of 28.02 grams per mole, and use that as my relationship. And I found a value of 0.935 grams of nitrogen in that breath of air. So Avogadro's number tells us how many particles we have in 1 mole of any substance, whether it's an atom, a molecule, some other particle, whatever it is. That value, 6.022 times 10 to the 23rd, provides a relationship that allows us to know how many particles we actually have, or to determine the mass of any number of particles.